Good morning, team, and welcome back. I'm Corey, and we're about to get started on day 8 of Advent of Code in Rust. If you missed my previous days, go check out the playlist up top for all my solutions, and don't forget to like and subscribe for more videos. Let's get started. Okay, day 8, let's dive right in. Day 8, Treetop Tree House. The expedition comes across a peculiar patch of tall trees all planted carefully in a grid. The elves explained that a previous expedition planted these trees in a reforestation effort. Now you're curious if this would be a good location for a treehouse. First, determine whether there is enough tree cover here to keep a treehouse hidden. To do this, you need to count the number of trees that are visible from outside the grid when looking directly along a row or column. The elves have already launched a quadcopter to generate a map with the height of each tree, your puzzle input. Looks like this. Each tree is represented as a single digit whose value is its height, where 0 is the shortest and 9 is the tallest. A tree is visible if all of the trees between it and the edge of the grid are shorter than it. Only consider trees in the same row or column. That is, only up, down, left, or right for a given tree. All of the trees around the edge of the grid are visible since they are already on the edge. There are no trees to block the view. In this example, that only leaves the interior 9 trees to consider. The top left 5 is visible from the top and left. It isn't visible from the right or bottom since other trees of height 5 are in the way. So equal means it's not visible. The top middle 5 is visible, yep, and then the top right 1 is not visible from any direction. For it to be visible, there would need to be only trees of height 0 between it and an edge. The left middle 5 is visible, but only from the right. The center 3 is not visible from any direction. For it to be visible, there would need to be only trees of at most height 2 between it. Yeah, okay. With 16 trees visible on the edge and another 5 visible in the interior, a total of 21 trees are visible in this arrangement. Consider your map. How many trees are visible from outside the grid? Okay, so I just need to do a count of visible. Okay, so I think we need to parse this to a grid of like width by height, and then from there we'll just do some grid manipulation kind of logic. Okay, so let's get started here. Treetop Tree House. We'll go back out of our day 7. Cargo new. We're making a library. It's 8. Treetop Tree House. Tree House named Treetop Tree House. Except tree house is 2 words apparently. Okay, there we go. Add it to our cargo workspace, as always. 08 Treetop Tree House. House. Yep. Sure it did. Sure. Okay, now we should be able to do cargo test inside 8, and there we go. Off and running. Is there a diff on 7? Did I not commit some 7? Nope. It's just VS Code being a little silly. Okay. So let's see. Let's just get something. Let's get our example input added. New file, example input. Insert. Okay. And let's go and let's create a struct for, like, is this a forest? Reforestation, planted trees in a grid. Doesn't really tell me. I'm gonna call it a forest. And it has some trees. And this is a vec of tree. And I'm doing vec because I just don't know the height and width right now, and I couldn't do like some const generic thing, but I don't know if I want to do that right now. So I think I won't. Okay, so we make this a tree, and a struct tree has a usize, which is the height of the tree. That's all it has. So we're gonna do this. We haven't done a struct that's not a bracket with named things. You can also do structs with just unnamed tuple style. So we're just gonna do that for our tree. Trees are just usizes. Okay, and then we'll do our impl for forest. Has a function, parse, like usual, input, string, goes to a self. And then outside of this, we're gonna have a function part1, which again is an input string, and this time it goes to a usize because we're counting the number of trees. And like we wanted to let our forest equal forest parse the input. We want to debug out a reference to the forest and return a to-do to make the compiler happy. This wants our derive for debug. Awesome. Derive may only be applied to, oh, put it in the wrong spot. There we go, both of our structs now can be debugged. This just doesn't actually return the thing. Okay. Let's get, so we have our input, we can get it into lines and then characters, and I think that's what I want to do. So input dot lines dot map, each line, I want to do line dot characters dot collect, and then collect this. Let forest equal, so this is just going to be a cars. I don't want characters, I want characters.map tree. Just construct trees from them. Oh, I guess I actually want to do a map to c.parse, which I actually don't know if I can just do on a character. No method parse found for character. Yeah, I just wasn't sure. Can I just like to Esia here? Dot as string dot to owned? But I don't really think I want to owned. I want, oh yeah, to string. That'll work. And then we can parse it. Map to parse.unwrap. Lots of stuff going on in this map at the moment. Okay, here we go. So our forest, this is really more the trees. And then I can do a self of trees. And that actually might be all of the parsing that we need to do. We just look at all the lines, get the characters, map the characters to a string, just because that makes it easier to parse. Then we map to our tree constructor, which just holds the usize. Okay, that might parse this out. Function, example, input, that's just example part1. I just don't need to write input. Let input equal include string of example.input. Let answer equal part1 of input. Answer equal answer is 21. Is that the answer? 21 trees are visible. Okay, awesome. Okay, so I now want to know if a specific tree is visible, but to do that, I think I really want to think about trees as their XY coordinate, not just the tree struct, because the tree struct is just a usize, and that doesn't really help me know where we are in anything. But I'm just talking. Let's do this and see if our parsing looks reasonable. So the last row is 35390. 35390. Okay, so that looks like it parsed correctly. And I actually don't think I care about which is X and Y. All I care about is moving in either the X and the Y direction and seeing if I am visible or not from any direction. Okay. So let's see here. Let's see, what do I want to do first? So we have parsing working out well. So let's just do let width equal forest dot, let's just add a width method to it. Let's just get width and height out of here, and we'll just write these as methods on my forest because it seems like the way to do it. Generate the method for width. The width is going to be self.trees at 0.length. Usize, and then we're going to do height, which is self.trees.length. And this will then again return a usize. Awesome. Okay, so we have the height and width. So I think I want to just do for I comma j in 0.width zip with 0.height. I think this will do what I want it to. Let's just see if it does seem like it's debugging out I and j correctly. No, it's gonna be before this, so we're gonna do 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Okay, so that's not what I wanted. So zipping them, that makes sense though. I think I just want to do a nested one because that's the easier way to do this. For I in 0.width, do something for j in 0.height. Okay, there we go. And like now I could debug out I and j, but I am more confident now. Yeah, zip makes sense that it didn't do what I wanted it to. So let's run the test here, and there we go. This looks more right. We go through all the i's, then we go through all the j's. Okay. So the easiest way that I can think to do this is let visible coordinates equal a vec, empty vec. This is going to be mutable, and this is going to be a vec of a tuple of usize. So this is going to be my ij that I just made here. Perfect. So we could just make a, like, I'm not sure we actually need this, but we can do a type of coordinate equals usize. And then this could be a vec of coordinates. Okay, so forest dot is visible, and we pass it a I comma j. If forest dot is visible, we want to do visible coordinates dot push I j let c equal I comma j, because now I can just do that and that. That's a reference. Let's generate this method. Function is visible. Reference to a coordinate is visible. Okay, so now I think what I want to do is function is visible in the up direction. Again, you go to a Boolean. I like that it knew that I wanted the is method to be this thing. So is visible up says let height equal self.trees. So let's actually do a function get tree, which takes a self and a reference c, which is a reference to a coordinate, and returns a reference to a tree. So self.trees at c.0 at c.1. Expected tree found tree reference. Awesome. So self.get tree at c.0, that's its height. And then for let y equal c.1 for y plus 1 dot dot height try removing for new y in that. Cool. I think it's now mad that I'm not doing anything. Eventually we will return true. Inside here though, we will do let new c equals c dot 0 comma new y, let t equals self dot get tree at new c, if tree is less than or equal to if, how do I want to say this? What do I want to do about the directionality here? So you're visible if there are we're doing visible. Okay, so if there is one that would hide you. So if t is greater than or equal to height, return false. T is a tree, so t dot 0 is greater than height. So if you're hidden, return false, else return true here. Okay, that makes sense. And then I think I just want to like repeat this for different things. So like is visible down, new y in 0 dot dot y. Get rid of the oops, nope, I didn't want that. I thought there was going to be just get rid of the parens. Okay, so now it's just the same. We just changed our iteration here. Okay, wow, this could be really easy. So then is visible from the left is, okay, so now we need to go on x at c0. New x is from 0 to x. New c is new x, and this is c dot 1. We get the tree if the height, yep, okay, and now I just need another one for is visible from the right. There's a good chance that I could have done this without quite as many of these, but this is the way that just seemed to make the most sense to me. X plus 1 dot dot width. This height isn't what I want here. This is, I want like self dot height. Wait, no. This was the right height. This one here is the wrong height. Self dot height. And then this, where it's width, this wants to be self dot width. This is getting the width of the forest, not the height and width of the tree, because that didn't make sense. Because the height is always that. Cool. So then is visible is self dot is visible down, or self dot is visible up, or self dot is visible left, or self dot is visible right. Awesome. Okay, and then I think we just go down to here, and this is just visible coordinates dot count dot length. Is that right? Yeah, passed. Awesome. Okay, let's try with my input. Get my puzzle input. Man, that's a big puzzle. New my dot input. Awesome. Go to my lib. Let's copy this for My part one. Mine. It's not going to be 21, but that's okay. We get our answer of 1695. 1695. Awesome. Let's put that in our test. Sometimes I forget to do this. I forgot yesterday in the video overall to do that, but today we got it. Okay. Day 8, part 1. Commit anyway. Okay, and on to part 2. Part 2. Content with the amount of tree cover available, the elves just need to know the best spot to build their treehouse. They would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up, down, left, and right from that tree. Stop if you reach an edge or at the first tree that is the same height or taller than the tree under consideration. If a tree is right on an edge, at least one of its viewing distances will be 0. Okay. The elves don't care about distant trees taller than those found by the rule above. The proposed treehouse has large eaves to keep it dry. The elves don't care about the distant trees taller than those found by the rules above. The proposed treehouse has large eaves to keep it dry, so they wouldn't be able to see higher than the treehouse anyways. In the example above, consider the middle 5 in the second row. Looking up, its view is not blocked and it can see one tree. Looking left, its view is blocked immediately and it can only see one tree of height 5. Looking right, its view is not blocked and it can see 2 trees. Looking down, its view is blocked eventually. It can see 2 trees, one of height 3, then the tree of height 5 that blocks its view. A tree's scenic score is found by multiplying together its viewing distance from each of the 4 distances. For this tree, this is 4, found by multiplying 1 by 1 by 2 by 2. However, you can do even better. Consider the tree of height 5 in the middle of the 4th row. You get these numbers. It has a scenic score of 8. What is the highest scenic score possible for any tree? Okay, so we need to implement scenic score, and then we're just gonna max it, basically. Okay. So, I think I want to implement scenic score, which is going to be like kind of like my is visible, but not exactly the same. And I think I want them in each direction because I want to multiply them all together. So like function scenic score for a self and a c, which is a reference to a coordinate. It's going to return a u size, just everything multiplied together, and it's going to be self.scenic score up for c times self.scenic score down for c, and we're going to keep going, except I'm just going to tell it to, oops, nope. I want it to implement, yeah, generate this for me. Generate that for me. These return U sizes. U size. So I bet there's a way to calculate my above things from my scenic score, but I'm not positive what that would look like. So I'm going to do them separately, and I guess like if we ever wanted to refactor this, that's something to think about. So scenic score up is going to be a lot like is visible up, except we're going to count the things. So let's go, yeah, something like this. So my height is this, and the visible score is counting up the trees I can see. So we stop when we hit, stop if you reach an edge or the first tree that is the same height or taller than the tree under construction. But you count the tree that's the same height. You just stop going forward. Okay. So from counting up, so from going y+1 to height, I want to count the, I want to find, what do I want to do? Okay, so I think let's comment out this because it's not what I want, but I might want to use it as a reference. So I think though what I want to do is I want to go from y+1 to self.height. And then like, what does position take in? It takes a predicate. Okay, so it's the closure, which is exactly what I want. So I want to find the position where C, where like, I think I want to get the tree from coordinate. Let T equals self dot get tree from C. Yep. And then T, I want to find the one where T dot 0 is greater than or equal to height. That's my tree height. Um, let the first like first blocked or something like that. That's an option of a U size. So then if let sum, so if there is a first blocked, then I think I want to do first blocked minus my y. That'll tell me how far we are from that way. And if it's the first blocked, we just do 0 here. Oh, equal first blocked. I have to actually do my if let correctly. Expected, okay, yeah, so this wants to be this. And this then is new C. And this is not C, this is new Y. And then new C probably wants a reference. Okay, so there we go. And I think the 0 here is right. If you're on an edge, to measure the viewing distance, if a tree is right on the edge, at least one of its viewing distances will be 0. Awesome. Okay, so now let's do 0, 1, 2, 0, 1, 2, 3. So 2, 3 should have 1. So let's do a test of that. Function test visible test scenic score up. Scenic score up. On the example. So here, let's add the test attribute. That's how Rust knows that it's actually going to be a test. And actually, yeah, input, but then let forest equal forest, parse our input, and then let score equal forest dot scenic score up on a reference to, oh, actually, no, a reference to 2, 3. Assert equal that score is 0. Score 0 is like kind of the easy one though, so we'll see if we need to do something different. Attempted to subtract with overflow on line 138. So that is first blocked minus y. Okay, so the first blocked one minus y. How is that? Okay, well, let's just do a debug then, because I'm confused. I would have thought that was not going to subtract with overflow. Test. Close the last one, close the last one. Okay, first blocked is 1 and y is 3. Okay, so that's just not, okay, first blocked is actually the answer, because this is getting the position, I'm getting the position. I think if I did find, what would that give me? Yeah, because I'm going over these, so I could do find, and then that would give me what I'm looking for here. Expected reference, found a reference. Is this gonna be what I'm looking for? I'm not sure this is better, but I just want to make sure that this makes sense to me. This is 5, 3. First blocked is 5. I was at 3. Why is 4 not the first one blocked? Oh, yeah, because that... Wait a second. If I'm going up here, that doesn't seem right. First blocked. Okay, let's... Well, is the answer 0? The answer is not 0. The answer is 1. Okay, well, that's better. The answer is not what I said it was. You can see 1 tree. So this scores 1. And I think I had it right before. I think if I just do this as position, that doesn't need that anymore. And then the answer here is just first blocked. And it's not really first blocked. What is it? It's distance to first blocked. Oh man, and then I didn't actually do the rename. Distance to first blocked. This is really the same. It's distance to first blocked again. Distance to no. Copy. Paste. Paste. Okay, there we go. Now is this gonna give me 1 here? Oh, didn't want that. Passed. Okay. So up is working correctly now, and now let's implement some other ones here. I don't need this whole comment anymore, and really the only difference here is gonna be here. This is the only thing that's gonna change when I write down. So let's just do it this way first, but I kind of want to refactor this. So height is here, y is going to be from 0, and this is just going to be from 0 dot dot y. That's not what I wanted. Coordinate dot 1. Okay, so then down, let's test down here as well, just to make sure that this is still what I'm looking for. Oh, it's actually not going to be. Because for down, I need to do this in reverse order. No reverse for range. Reversed doesn't exist. I think I could do that on iter tools, but that's okay. So let's do let range equal a vec of something. We'll make it mutable for just a second. It's not my favorite, but this is fine. 0 dot dot c dot 1 dot collect range dot reverse, and then this is range dot into iter. There we go. So down, the problem was that I didn't want to go from the bottom of the forest up. I wanted to go from my thing down, and I don't think I could have just done it in the opposite range. I think I have to do it and reverse it. So now let's test the down example. So down from the same thing, from the same spot here, down gives us, you'll see 2 trees. Nope. I left, it wanted a 0, I expected to, or I want it to equal 2, but it's giving me a 0. Okay, so, so this should then, yeah, let's just see what it's given me in my function, because that seems like it should be giving me what I wanted to, but it's not. Okay, so down, we start at, well, let's debug out my range here. This does say down, this does say down, perfect. Okay, so 2 1 0, yeah, okay, because we're here, so then 2 1 0, perfect. Yeah, okay, so that range looks right. We keep the x the same and we use a new y. What's going on here? This feels like it should be right. Distance to first block, that's an option. Let's just see what we get out of here. Sum 0. Okay, so it's not a none. We're getting a sum. But it thinks that if I go down 0, meaning the first thing. Oh, wait. I want to... I'm actually not convinced up is working. I think up might be working for the wrong reasons here. We want to keep going until you find one that has height equal or greater than me. T dot 0 is greater than height. That doesn't make sense. For this one even. For up, if we're looking up, starting from one above you to the end, and we want to find a position where T, this one should be hitting the none case. Distance to first blocked. Yeah, how is this giving me the right answer? I feel like it shouldn't be. Distance to first blocked is sum of 1. Also, wait, how is sum of 1 even an option here? Because position takes a closure that returns true or false. It applies this closure to each element in the iterator, and if one of them returns true, then position returns some index. If all of them return false, it returns none. It's short-circuiting. In other words, it will stop processing as soon as it finds a true. Yeah, but that should mean that there's only, like, there shouldn't be very many things here. Up. Yeah, I know I can remove the parentheses. It's fine. You're gonna, oh, there we go. 4, to 99. Oh, am I running this on the wrong input? Oh, man. So that one was just working on a coincidence. It shouldn't have been working. That's the problem here. Okay, let's try this again. Now it's gonna fail. On 1 should equal 0. So we're going from 4 to 5. Now we get distance to first blocked is 0. Okay, this is right now. Okay, so up is still wrong, but that's fine. I was using the wrong input for the whole time there. Okay, so this is gonna check for... Wait a sec. Was that just printing out... Yeah, okay. No, it's gonna find none. And if it finds none that are first blocked, then I think oh, this is the one I want. It's not 0 though if they're distance to first blocked. This is gonna be self dot height let range equal this. Range, and then so this would just be range dot length. Oh, let range length equal range dot length. And then this then is just range length. Because if it's mutable, then we're obviously going to like mess with it. Okay, so range is this. We get the range length. Okay, let's try that. There we go. That's passing now. Okay, so yeah, this is gonna be different. Okay, I think we're just gonna copy and paste this for now. Not my favorite, but I think it's what we need to do. Okay, and then range here, though, is going to be pretty wrong. This is going to be 0 dot dot y. Except what I really want to do is mutable this dot collect. This is going to be to a vec of something. Range dot reverse. And then this is range dot into iter dot position. Okay. Don't need to debug that. Let's not debug that, and let's see if now we pass this test. No. Assertion failed, left 0, right 2. So we got 0 again, I believe, out of this one. Okay, so what is this? Did we get a distance to this or did we not? Distance to first blocked is sum of 0. Okay, so it thinks the first one we ran into was blocked. That's not true at all. Let's debug our range. I just want to make sure that this looks right to me. Yep. Okay, so then down, it should just be going down. 2, 1, 0. Yep. So 2, 1, 0. How is the first block sum of 0? Position, distance to first blocked, position got 0, which means it thinks it's the first one. But that's like just not true, right? Debug out a reference to our tree. And the reference to our tree has a height of 3. And so isn't our height higher than 3? I feel like I might have. Yeah, no, get tree. Yeah, okay. What's going on here? Like, did I rewrite height? No, I didn't. Um, height 3. Height 3. 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2. Oh, okay. Am I messing those up? Am I looking at not the right coordinate according to my system? That would be interesting. Do I want 3, 2, and does 3, 2 just happen to have the same answer for this one too? So up still passes. Down now passes. Okay. I had my coordinates wrong for my examples. All kinds of issues here. Okay, but now up and down seem to be working. So now I guess I do left and right. Scenic score left, and actually let's just copy my answer here. Left 1. Left. Scenic score left is 1. Okay. And so scenic score left is height is that. We're going to count x's though. We start here. Our range is going to be from x plus 1 to self.width. Wait, surrounding parentheses, that's fine. Distance to first block. This is where this is not right. This is gonna be renamed to new x. So then this is new x, comma c dot 1. Okay, that hopefully is all I need there. Left, passing, okay, and then right. Right here has 2. Right, and the answer is 2. And then we go up and we copy the left one. And we paste it down here as the right one. And this is one where we actually need this. So this is x. We place it as x, as 0. Y to x. Reverse it. Into iter. This is right though now. Uh-oh. Did I like mess that up, or is left still right? Yeah, okay, cool. They're in the wrong order, but like that's fine. Right doesn't pass yet. Is it just failing, or yeah? Right example, I expected, oh, right, is right two? I can see two trees. Its view is not blocked. Score right. Okay, so it should be not blocked, so I should be getting into here where range length should be 2. Debug out, distance, first blocked. This is right. Yep, scenic score right. Scenic score right. We've been doing 3-2 for all of these. Okay. Um, Distance to first blocked. Okay, so it has a distance to first blocked. That's interesting. It should not. Okay, we just messed something up in score right. That's okay. So from... Oh. Oh, left is where we're gonna need this. Did I mess this up? Yeah. Left is where we're gonna need to go from 0 to x. And right was where we just need to go to the end there. Into iter. Okay. Left still passes. Right still doesn't pass. We get a 1 instead of a 2. Distance to first blocked is none now. Okay. But we get 1 instead of 2. Why is the right example here having the wrong length? X plus 1 to width, range length, debug a reference to range, and then a reference to range length, because why not? Right now is giving me range 4 to 5, range length is 1. But no, there should be 4. So this is 0, 1, 2. Oh, wait. This is... I'm calling this 3, 2, I think, right? Because my last array is this. So my first array is this one. Oh, wait, this is 0, 1, 0, 1, 2. Is this 1, 2? Like, am I looking at, like, the completely wrong thing for all of these? That just happened to work? So my whole coordinate system all wonky. Right, no, right doesn't pass now. Left still passes. Down doesn't pass now. Up doesn't pass now. Okay, I need to understand my parsing. Let's make one that's kind of like this, except for parsing. Example parsing. Let forest equal forest parse our input. Assert equals that forest dot get tree forest dot get tree for that's not what I wanted to copy. A reference to 3 comma 2 dot 0 is 5. Okay, parsing. That is 5. Okay, so then what is 1, 2? Is 1, 2, 0, 1, 0, 1, 2? Is that also 5? Yep. Okay. So then is 0, 1, 0, 1, 2, 3? Is that also 5? Are these all 5? No. 1, 3 is 1. 0, 1, 0, 1, 2, 3. No, wait, it's 1, 3. 0, 1, 0, 1, 2, 3. No. 0, 1, 0, 1, 2, 3. Okay, so 0, the first one's the y direction, and the second one is the x direction, starting from the top left. So 1, 3 is 0, 1, 0, 1, 2, 3. Yeah. So then 0, 1, 2, 0, 1, 2. 2, 2 is 3. Place 2. That's a 3. That's a 1. Okay. 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 Wow. My coordinates were just super duper wrong for all of these directions. And I guess for the visibles, it didn't make a difference because I was just oring it. But for the scenic views, it's very wrong. Okay. So it's y, it's y comma x starting from top left as 0, 0. Wow, okay. Okay. But that just means the scenic scores of everything are wrong. So the scenic 3, 2 here is 0, 1, 2, 3, 0, 1, 2. Yeah, so it's the same 5, unfortunately. Okay, so I want 0, 1, 1, 0, 1, 2. I want 1, 2. Replace 1, 2. Replace 1, 2. Okay. But now all of these are going to be wrong because my examples don't make sense. So scenic score up is actually going to be what I've written as down. I think I just need to flip them. So down flips, up flips, left flips, and right flips. The parsing didn't change. Perfect. Up, no. Down, yes. Left, yes. Right, no. Okay, so up and right are broken. Let's look at up first. Up from 1, 2. If we're going up from 1, 2, we're gonna... I think these are all wrong. I just need to look through all these. Okay, so down. Y is the first thing here, which is absurdly silly, but that's okay. New Y is here, and then C dot 1 is there. Okay, so distance down now. Down means we're actually going up from numbers. We're going from the y plus 1 to height. Yep. Okay, so up means the opposite. We're going to go from 0 to y, but this is still backwards because it's c dot 1. Okay, and then left means we're going to go down in the x direction. So we're going to go from... Going left means we're going to count... Oh, so left and right probably didn't need to flip. Let's make this right then, because right's going to go from... Oh, well, this is the second thing. The y here is the first thing. That was the other thing that I needed to change. I got that one right here. Okay, so x is this direction. Going right means we're going to go from there to there. That is correct. This, though, is wrong. This is c dot 0, and then this is new x, because all of my coordinates are messed up. And then left is going from 0 to this, but we got to do it reversed. X is referring to the y's, so this one goes c dot 0, and then new x. Okay. Parsing still works. Part 1 still works. Part 1 still works. Up works. Down. Does not work. Dang it. Left. Does not work. Right. Works. Dang it. Okay, so I'm broke left and down now. Down is supposed to be 2. It's giving me 1. Okay. Okay, so let's look at down. And let's add a debug for distance to first blocked. And let's also do a debug for range, comma, range length. Okay. Down. Down example. Run test. Okay. The range is from 2 to 5. The range length is 3. The distance to first blocked is 1. Okay, so if I go down, though, from here, distance to first blocked is 0, 1. Oh, okay, so do I just need to add... Yeah, these are 0 indexed. That makes sense. So for all of these, it's distance to first block plus 1. 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 Okay. Right. Let's just do it for all of these right now. Cargo test. Everything passes. 7 passed. Okay, awesome. Phew! Okay, so now I think we are ready to write the part 2. Where part 2, actually, do I have a thing for... Did I start that? Scenic score, yeah. Time self dot scenic score left for C. Time self dot scenic score right for C. Awesome. Okay. And then let's test out scenic score overall for the ones I know it for. A test scenic score example. Substitute that for example globally. There we go. Just spelling. Okay, so a scenic score for 1, 2, and then I think the answer there is 4. Let's do this. Put it there. Scenic score for that one's 4, and the scenic score for 0, 1, 0, 1, 2. Yep, so 0, 1, 2, 3, 0, 1, 2. Oh, so this is 3, 2. Oh my gosh. And then this one is 8. Passing. Awesome. Okay. Phew. Okay, no more debugs. Okay, scenic score. Scenic score is literally just part 2. No, it's not. It's the... What is part 2? Consider each tree in your map. What is the highest scenic score possible? Oh, okay. That's pretty easy. Function. Part 2. Input. String. usize. Let forest. And then let's just do... I really wanted this to be an iterator thing, so I can just do a call to dot max on it. What I really want to do is something like... I want to do something where I just do 0 dot width dot permutations. Yeah, see, I don't have a thing. I think there's one on iter tools, but let's just do let mutable. No, I really want to use that. Okay, let's just add iter tools. That should be easy enough. Cargo add iter tools. Awesome. Okay, so now I should be able to do 0 dot width dot permutations of 0 dot height. And then here we want to map these to, this is a coordinate basically, and then we want forest dot scenic score for the coordinate. And then we just want to do the max, I think, because I just want the max scenic score. C is not what I want here. Permutations. What does permutations return? I thought. Oh, it returns a vec. Is there a tuple? Iter, tools, permutations, Rust. But I don't want permutations. See permutations for more information. But what I want is like permutations with a tuple, which I can totally like just do. But I kind of thought there was just a permutations tuple or something. Permutations. There's Cartesian product. Okay, well maybe we just do this with a vector. I really thought there was a tuple version of this. Collect tuple. But that's not really what I'm looking for. Okay, that's fine though. It's like a little frustrating, but not a big deal. A reference to C at 0, comma C at 1. Like I don't even really, I just need to found unwrap. Unnecessary double parentheses, cool. Now what? Expected, wait, permutation. Oh, so permutations might not have been what I wanted. Power set. Per iteration, the power set is linked to n, where n, no, power set, you don't give it anything. I want like a dot product, I guess. Dot product, or that's the multi-Cartesian product. Is this what I wanted? Return an iterator adapter that iterates over the Cartesian product of all sub-iterators returned by the meta-iterator self. To generate a product of iterators using multiple types, use I product. Oh, okay, well, I don't think I need that, but... Oh, but that actually looks perfect. Okay, so can I just do I product of 0 dot dot width, 0 dot dot height? And then does that just let me do a C there? Because now C should be a U size to a U size. Import it. Aha! There we go. Let's take this one. Okay, this might be part 2. Part 2. Whoa, okay. Part 2 on input. And then the answer for this, the treehouse singing score is 8, which is the ideal spot. So 8, I think, is what they're telling me. That is the best spot. Passing, awesome. Okay, let's fix the Clippy that it's mad about. I just don't actually use this here. We just use this iProduct macro. Okay, let's do this because that'll make things stop thinking they're unused, which we haven't always done before, but if we tell it that the part 1 and part 2 are public functions of our library, it will stop complaining that they are unused. Okay, there's that. And then the last thing that I want to do is take this for my input, my, and my. It's not going to be 8. The answer that it's going to give me is 287040. 287040. Yes, awesome. That is the answer. 287040. 287040. Yay! Okay. And that then, let's just check this, is gonna wrap up day 8 of Advent of Code in Rust. Let's go ahead and make a commit here. Day 8 part 2. Okay, there we go, and that is going to officially wrap us up for day 8 of Advent of Code. I hope you enjoyed this video. If you did, give it a like and subscribe to my channel for more videos. Day 9 will be coming at you real soon. Thanks. Bye.